All right, welcome to part two. So we are referring to the same graph that I had you copy for part one. And I'll add the arrows again to indicate um, that the graph keeps going. So what we're looking at now, this is sort of our review of pre-calculus. What is a limit, right? So a limit, the definition of a limit is the value that a function approaches as the input or x value approaches something else, right? So as x approaches something, the graph is approaching the y value. So for example, we'll look at this first question, the limit as x approaches 2 of f of x. So here is where x is 2. And you can see that from the left and from the right, the y values are getting closer and closer to 1, right? Um, for the next question, so the limit as x approaches 0 of f of x, right? So here's where x is equal to 0. The actual value of the function is 4, right? So if I asked you f of 0, you'd say, well, f of 0 is 4 because that's the actual point. But what the function's approaching, what it's getting closer and closer to on both sides, is actually 1, right? So that's the difference between a limit and the actual value of a function. The key word is approaches. What's it getting closer and closer to, right? Okay, so the last example here is what is the limit as x approaches 1 of f of x. Okay, so right here, it looks like we are approaching -1. Okay. So the last thing I want to leave you with is that in order for a limit to exist, the limits on the left side and the right side, limits as you approach from the left and from the right, need to match. So if I asked you, for example, what's the limit as x approaches -1 of f of x, right? Um, well, from the left, you're approaching negative infinity. From the right, you're approaching positive infinity, right? Those limits are not equal. The left and right limits are not equal. So if they are not equal, the limit does not exist. Okay. So that's our introduction to limits. We are now going to have you all practice and work on some example problems.